any rate, it is a singular privilege to introduce our friend here. David Vangsness has been a important supporter of free thought in the Tampa Bay area. He's a member of CFI, has for a large number of years headed up the CFI Book Club.
And CFI stands for what?
The Center for Inquiry, which is part of the national organization of groups, and of course it's mainly the center itself, which pursues a distinctive intellectual approach to the questions that revolve around free thought. And I have a great deal of respect for what they do, and I'm a member myself. But at any rate, I digress. The point we're here to look at today is a discussion about evolution and some of the recent discoveries that cast light on how we came to be. And David, I know, has always done an excellent job, and I'm looking forward to his remarks beginning right now. David?
Well, thanks, Jim and Judy. Appreciate it. All right. Well, thanks for all being here. Today, I'd like to tell a story, as Jim was saying, about human evolutionary history, specifically a phase of human history stretching from about 300,000 years to 40,000 years ago. And one of the things that makes this period of our history so interesting to me is that it was a time when we were not alone. At least two other members of the Homo genus were living at that time, now extinct, and often sharing the same geographic areas and occasionally in various ways. Is how much our understanding of this period of our history has exploded just in the past 10 years. Including the discovery of a previously unknown hominid species. These advances in chemistry, paleo, anthropology, and computer science have made this increase in our knowledge possible. One is the great advance in genetics and DNA chemical analysis, and our ability to tease even its signatures from some truly ancient fossils, some of which we'll be discussing date to 80,000 years ago. And it wasn't even possible to get DNA from a fossil. The current age record for DNA extraction right now is a 700,000-year-old horse bone found encased in Greenland ice. And that's pretty mind-boggling when you think about almost 750,000 years ago, this animal's been dead, and we can get DNA from their remains. In addition, progress in both computational power and new analytical techniques have shed much light on how these related species interacted with one another and how and when they moved about from one place to another. I'd like to begin by introducing the three main characters in our story: Neanderthals, Denisovans, and Homo sapiens. But before I do that, I'd like to introduce one more minor but still very important character, and that is Homo Heidelbergensis. And hopefully you can't see my screen. How's that? Can you see my screen?
Yes. Homo Heidelbergensis.
There it is. Okay.
You're number one.
And now it's gone.
Okay, good.
It's coming up again. There you go. All right, now you're fine.
And Homo Heidelbergensis, and I can't, oh, there it is. Okay. That would be this handsome fella. I'd like to run across this guy in a dark grotto somewhere. Homo Heidelbergensis evolved in Africa about 700,000 years ago and was a species of Homo erectus. The first fossils were discovered in 1907, and there was several subspecies of this hominin spread across the African continent. Besides being important as possibly the first of our genus to build shelters and bury their dead, he's important to our story because he's considered by anthropologists to be the best candidate we have right now as a common ancestor of all three of our main characters. His toolkit was similar to that of Neanderthal, and anthropologists consider him, some of them consider him to be actually an early form of Neanderthal. But whatever you want to call him, he was a transitional species between Homo erectus and Neanderthal and Denisovans, and also thought to have led to Homo sapiens through a related species, Homo Heidelbergensis. So let's go ahead and move on to the first of our main characters, Homo Neanderthalis, and hopefully I can advance this. Oops. Neanderthals evolved in Eurasia about 400,000 years ago, and the first recognized Neanderthal fossil was discovered in Feldhofer Grotto in the Neander Valley of Germany in August of 1856. We currently possess about over 400 soft fossils in our possession, so we have a pretty good idea of Neanderthal's body architecture. And you've probably, this is one of the early complete skulls that was found. Probably seen these representations before of Neanderthals. Perhaps some of you have even had one for a boss or a colleague. Their body architecture was cold adapted, so they were short and stocky in order to preserve heat because they were adapted to an ice age environment, and they weren't very tall, maybe 5.5 feet, but extremely strong. You definitely wouldn't want to get into an arm wrestling contest with one of these guys. They were pretty tough characters, and but based on their material culture, they don't seem to have been as proficient in symbolic thinking as we are. But they were tool makers. They had control of fire. And more likely, they did possess at least a rudimentary language. And one reason we think this is possible because of the fossil evidence of a bone called the Hyoid Bone. Hyoid Bone is actually also possessed by some of the higher primates, but it's in a lower position in the neck. And humans and Neanderthals, it's higher in the neck and it anchors the back of the tongue. And it makes it possible for us to have the, the more complex vocalizations necessary for language. So most anthropologists consider this pretty good evidence that they did in fact have language. But it's also, it's hard to imagine that they could have, been conducted the social relationships that they did in order to survive, and also work together in complex and dangerous activities like hunting mammoths without some form of language. So I think that's a pretty good assumption. And they did go extinct about 40,000 years ago. And this is a map of shows you how broadly they were distributed. Really covered a very large range, all the way from Iberian Peninsula to China. And these are some of the more important sites where fossils have been found. So let's go on and talk about the next character in our story, and that would be Homo Denisova. I'm giving you 3 names for this one because it is such a new hominin. There's still a lot of discussion about taxonomically exactly where to place Denisovas, but The most common one, and the one we're going to use today, is Homo Denisova, but sometimes referred to also as Homo Heidelbergensis. It was found in the discovered in the Altai Mountains. That's where they got that name. This third one I don't really understand because Denisovans were really much more closely related to Neanderthals than they were to us. So maybe Homo Neanderthalis Denisova would have been a better term. But anyway, we're going to go with Homo Denisova, and that is the one that's used more often. They were discovered in Denisova Cave, which is a permafrost cave located in the Altai Mountains in Siberia, and got its name from a hermit named Denis, who made his home in the cave in the 18th century. And was kind of a lucky guy because now he got himself named, got a whole species named after him just because he set up housekeeping in this particular cave where the fossils were found. But the first fossil that was found was a finger bone, and this was in 2010, and it was first identified as human, but later DNA analysis revealed it to be a hominin genetically distinct from both Neanderthals and Homo sapiens, and it was dated to around 30,000 to 40,000 years ago. Denisova Cave is thought to have been occupied at times by Neanderthals, Denisovans, and humans over a time span of about 300,000 years, and fossils from all three species and associated artifacts such as ornaments have all been found there. And here are some the excavations in progress. The digging season there is very short. You can imagine it's in Siberia and it's in the mountains, about 2 months long. So, you know, they really have to, archaeologists really have to make their time count when they're there. It's difficult to even get to in the wintertime. Here's a selection of some of the artifacts that have been found there. A recent, this is a side note, a recent analysis of soil samples taken from the cave has created somewhat of a controversy about the origin of the fossils. In all the samples that were taken, no carbon deposits were found that would be indicative of cooking fires, despite the fact that all three species possess fire. But there were found fossils of wolves and hyenas, as well as their coprolites, which if you don't know what that means, a coprolite is a fossilized stool, and in abundance in the cave. So it's been suggested that the bones may have been carried in there by wolves and hyenas, but they must have been very fashion conscious because they apparently brought the jewelry in with them. And so I think it's unlikely that happened. I think eventually they will find carbon deposits in the cave. So one of the Denisovan fossils that was found in the cave was from a girl who was a hybrid. Her mother was a Neanderthal, and her father was a Denisovan. And I just think that's so amazing. It's been known for a long time that the two species interbred with one another, but this fossil represents nature caught really in the act of hybridization. And really it's incredible that it was even found. But it does indicate that perhaps interbreeding between these two species was actually pretty common. And again, they evolved in Eurasia about 300,000 years ago and went extinct about 30,000 years ago. And currently there are only 8 fossils known, so we don't have a lot of direct evidence about their body architecture. More than likely, they were cold adapted like Neanderthals, and they did have a similar toolkit. Denisovans are genetically more similar to Neanderthals than they are to us. And but a group of scientists recently attempted to recreate a head of Denisova just based on the genetic data. We know that certain genes control for certain things like the shape of the skull and so forth. So they took that genetic information and they created a bust of what they think they look like. So this is actually based on genetics. It's not based on fossils. So how accurate it is, we don't know, but I think it's pretty interesting that they were able to do that. And, you know, it's at some point in the future, they will find a complete skull, and we'll see how accurate it actually was. There's only one fossil of Denisovan found outside of Denisova cave, and that was a jawbone that was found in a site on the Tibetan plateau. So I think we can look forward to a lot more of these fossils coming to light in the future. And we undoubtedly will learn a lot more about these animals as time goes by. So now we get to talk about our third character. We get to talk about ourselves. And Homo sapiens evolved in Africa between 200 and 3,000 years ago. And one of the oldest known fossils is this one, which is from Morocco and dates to about 285,000 years ago. During the 1980s, there were two competing models of how humans may have evolved from more archaic species. One was the recent African origin model, which postulated that our species emerged from a single more archaic species. And then there was the multi-regional evolution model, which postulated that we evolved through interbreeding with a number of more archaic forms, as well as other related species across a large region. And but since the 2000s, the availability of data from archaeogenetics and from modern population genetics has led to the emergence of a much more detailed picture, which is intermediate between these two competing scenarios. And the recent Out of Africa accounts for the predominant part of modern human ancestry, while there were also significant admixtures with regional archaic humans. So our history is now understood to have been much more complicated, and you might say messy, than previously thought. So recently, the first large-scale migration of anatomically modern humans into Eurasia was thought to have taken place about 60,000 years ago. And that would have left a time span of about 20 to 30,000 years when the three species occupied the same geographic areas and interacted in various ways. However, there is also some tantalizing evidence that there was a much earlier migration out of Africa 200,000 years ago. A human jawbone found in Israel carbon dates to 180,000 years ago, and a partial skull from Greece, which is this one. This is dating to 210,000 years ago. So that was kind of interesting. We'll say a little bit more about that later. So, you know, we know that all three of our main characters lived in proximity to one another for at least 20,000 years. And we also know that Neanderthals and Denisovans eventually went extinct and were supplanted by anatomically modern humans. So let's look at a chart showing, based on what we know now about their DNA, how much is shared by these three species. So when I look at this chart, the first thing that jumps out at me is how much more DNA is shared by Denisovans and Neanderthals than by Neanderthals and humans or Denisovans and humans. And I think that's mainly due to the fact that, you know, these animals lived in proximity to one another for over 300,000 years, compared with living in proximity to humans for maybe only about 20,000 years. So I think that's the biggest reason, but that's a pretty significant percentage. There must have been a lot of interbreeding going on between these species. It's also interesting that Asians have twice as much human, I should say Neanderthal DNA, as Europeans do. And that's probably due to the fact either there were more of them in Europe, in Asia, I should say, or they just cohabited for a longer period of time. Africans don't have any Neanderthal DNA at all. So who wants to tell me why that is? Everybody's muted probably, right? Well, Neanderthals didn't evolve in Africa, they evolved in Europe and in Asia. So now I will say as a side note,
Neanderthals mostly found in Europe.
What's that?
Weren't Neanderthals thought to have evolved more in Europe than Africa?
That's right. That's exactly right. And that's why there's no Africans don't have any Neanderthal DNA. But I will say as a side note, there was a paper published about 6 months ago that claims to have found DNA in population, Neanderthal DNA in populations in Northern Africa. Somewhat controversial because it was a very weak signal, but to me, it's not, I wouldn't be surprised if it turned out to be true because it's not that hard to imagine that, you know, as Homo sapiens migrated into Europe and Asia, interbred with Neanderthals, that some at some point may have wandered back south into Africa again. You know, it could be a whole number of reasons why that may have happened. So, but in general, I'm going to stick with the 0% because most Africans have, all the Africans that have been tested so far don't contain any Neanderthal DNA. Neanderthals DNA has 3 to 6% DNA that comes from us. I think that's pretty interesting. I think the 6% was probably comes from Asia, and the 3% from Europe. And also, I think very interestingly, Denisovan DNA is showing a significant contribution, about 1%, from an unknown hominin that predates Neanderthals. So that gives us something to look forward to. It would be interesting to see what that turns out to be. My guess is probably a Homo erectus, since it's more archaic than Neanderthal. Possibly, you know, another form of a close cousin of Heidelbergensis is what that'll turn out to be. But so, what does this tell us? Oh, and the highest concentration of Denisovan DNA in humans is in Papuans of New Guinea and Australian Aboriginals. So what can all this tell us about how these species moved around? I mentioned earlier that a lot of the new information that has come to light in the past 10 years is partly a result of an increase in computational power and also some new analytical techniques. And enter this gentleman. His name is Alan Siebel. He's the guy in the blue shirt standing in the middle picture. He's surrounded by his research assistants from his team at the Cold Springs Harbor Lab on Long Island. Siebel is a computational biologist with a PhD in computer science, and he's developed an algorithm that accurately reconstructs ancient migrations by analyzing DNA samples recovered from fossils and also modern populations. And so how do we know that this algorithm works? Well, it's been tested using data from ancient populations whose migration patterns we already know and samples from their living descendants. And not only did it prove to be very accurate, but it was also found that it doesn't even require a large number of samples in order to produce accurate results. And his analysis also shows a strong signal of migration of humans out of Africa about 200,000 years ago. So there's some additional evidence that coming from DNA that there was in fact an earlier migration. But perhaps surprisingly, none of our DNA in modern humans comes from this earlier migration. 100% of it comes from the expansion of 60,000 years ago. So, you know, perhaps these earlier humans all died off, or maybe they were absorbed into the Neanderthal population. But all of DNA of modern humans comes from that later expansion into Europe. So the genetic data also indicates that Denisovans may have been interbreeding with Papuans as recently as 15,000 years ago, which is, to me, that's pretty incredible because, you know, you're talking about roughly the same time frame as when Asians were first migrating into North America across the Beringian land bridge. So we know at least they were there 30,000 years ago interbreeding, but it may have been actually even a lot more recent than that. Finally, the question remains, why did two very successful species, which have been around for hundreds of thousands of years, suddenly on geologic timescales go extinct after coming in contact with humans? Well, right now there are several competing theories of how that might have happened. And I just want to run through them real quickly. First one, adaptability. Understand this hypothesis, we have to realize that around 40,000 years ago, the climate in Eurasia was rapidly changing. And this was the end of the last ice age, and temperatures around the globe were gradually rising. And many of the animals evolved for cold climates began to disappear, such as the woolly mammoth and other megafauna. And Neanderthals and Denisovans would have had to develop the technology and hunting techniques to exploit new sources of food. And we know from what we know about for instance, the Neanderthal toolkit, that is their weapons and their stone tools, hardly changed at all over the whole 400,000 to 500,000 years of their existence. And that's in stark contrast with human technology, which was constantly being refined and improved over time. So this lack of adaptability alone could have spelled really the end for Neanderthals. I'm going to jump ahead to number 3 because I think that's tied in very closely with adaptability. Competitive replacement, it's the idea, it's sometimes also called Gauss's law. And it's the idea that even when you have two species occupying the same ecological niche, and they're both competing for the same resources, even a slight advantage by one will over time result in the extinction of the other. Competitive replacement simply means that one species has a species-specific advantage over the other. Certainly better adaptability in changing times would be a clear advantage. We've also looked at technological advantage, and this would be another. Others might be better language or better division of labor, superior cognitive abilities, or even the ability to run faster over longer distances. Any of these could have made the difference in which species would prevail. Violence is the idea that violent encounters between humans and Neanderthals led to the eventual extinction of Neanderthals. Both humans and Neanderthals at that time were hunter-gatherers, and human hunter-gathering societies are known to be warlike, very warlike, as they compete with neighboring groups for available resources. So it's not too hard to imagine that humans and Neanderthals also fought each other. In that case, Neanderthals would have been at a very distinct disadvantage technologically. Let's take a look again at this rendering of Neanderthal. You notice their spears, they're very large, they're very thick and very heavy. Probably weren't good for throwing a very long distance. Really what they were good for was, you know, walking right up to something and sticking it in them. So what do we know about the weapons about humans? Well, the oldest known projectile points associated with humans date back to about 70,000 years, but the oldest known bow dates only to about 9,000 years ago. So it's unlikely that Homo sapiens that left Africa 60,000 years ago were carrying bows and arrows. However, they did possess something almost as good, and that's this weapon called an atlatl, or spear thrower. Atlatl actually refers to the spear or the dart, but usually when people use that term, they're talking about the whole device. It's a very lightweight spear, sometimes has feathers on the back, and a spear thrower. And this can throw, accurately be thrown, tens of meters, and with a lot of impact and a lot of accuracy. Believe it or not, you can still, these are still in use today. There are people that know how to use them, and if you want to, you can even enter contests where people, are throwing these things. Here's a guy that's holding one that's apparently wanted to be a caveman, but they're very, very lethal weapon. And for Neanderthals, this would have been like bringing a knife to a gunfight. They would have been really at a severe disadvantage. So then we have pathogens and disease. I think that's pretty straightforward. I think all we need to do is look at what happened to the Native American populations when they first came in contact with Europeans to know how devastating it would be for Neanderthals if they were exposed to diseases to which they had no immunity. And then the last theory has to do with interbreeding. Some anthropologists have argued that Neanderthals didn't die out at all, but were simply absorbed into the Homo sapiens species through interbreeding. But I think of all the 5 possibilities, this is probably the least likely, because, and it really doesn't have a lot of currency with anthropologists today either, because I think you'd find a lot more Neanderthal DNA in our genome if that had been the case. Of the other 4, I think they all played a part to some extent. Which ones were more important, or how the scenario actually played out, that's something that's debated today, and I'm sure will be among anthropologists for a long time to come. So that's all I have, and open it up so anybody has any questions or comments.
Thank you very much, Dave. That was a terrific presentation. I think I learned a lot. And so did the birds, apparently.
Are those yours?
Let's see if we can get out of this. Can you, there you go. All right. Anybody who wants to raise a question or make a comment, if you go to, where is it, participants, then you can
I have something to say.
Hand.
May I please?
Helen,
I had my
I
had my DNA done by National Geographic, and I have 7% of the one we just talked about in my DNA, Neanderthal. And I also have a lot of other ones, Northern European, English, and so forth.
Yeah.
And it's 7% from them, not making 100% for me, but from their 100%, I have 7%. I have 48% of the English and 45 of the Northern European. And I also have, let's see, some Eastern also. So I have Neanderthal in me.
Did they say what percentage was Neanderthal?
7% from their DNA.
7%?
I don't know what that means.
Yeah, that's
Yeah.
Yeah. Most Europeans.
I mean, I'm not proud of it, but
well, we won't hold it against you.
thank you.
Well, there's nothing to be ashamed of by any means. Also, we have a couple of questions in the chat room. And one is from Jim Peterson. Jim, would you like to repeat your question aloud?
Yes, thank you very much, Judy. Yes, evolution has not stopped, as I understand it, and it's still proceeding. Dave, do you have any inkling as to any particular direction in which we may be physiologically evolving? We know we're culturally evolving all the time and at a rapid pace, but our physical dimensions are probably changing too in some ways. What do you think?
Well, it's a very, very slow process. So we can speculate, but it's hard to say for sure. One thing that many people have commented upon is the fact that over time we're becoming we're self-domesticating, becoming less violent as time goes by because of living in fairly densely populated groups with one another. So now that's partly cultural, but it probably does have a physiological component as well. So that's really the only one that I would want to speculate that's where we see a trend right now. But we are continuing to evolve, and hopefully, but it's such a slow process that somebody will have to dig up our bones and.
Thanks, David. Gary has a question in the chat room, and then we'll get to Bill and Linda who have their hands raised. And it is helpful if people will raise their hands. Gary wants to know if you could help us understand the basis for validity to the time frame references other than DNA.
Other than what?
DNA.
Well, the time frame doesn't come from DNA. It comes from radiometric dating. The most common being carbon dating, carbon isotope dating, and that's if there is carbon left in the sample. There are other methods as well, other radiometric methods, but most of the dates that I was referring to come from carbon dating, which uses the half-life of, I believe it's carbon-12, which is an isotope of carbon. And they know how much carbon was in the environment at the time that the animal died. And by seeing how much remains in the, of that isotope in the sample, they can estimate how long that animal's been dead. And it's actually very accurate, especially in more recent times, but usually plus or minus a few percent. It's a very accurate dating method. So that's where the dating comes from. It doesn't come from DNA.
Thank you. And Neil wants everybody to know he's outside with blue jays, so he's staying muted, but he also says it's C14. So.
I'm sorry, I didn't get any of that.
Oh. He's outdoor with noisy blue jays, so he's going to stay muted, but he wants us to know it's C14. And I think you said C10, but I can't remember exactly.
Oh, carbon 14. Okay,
Yeah.
nice. So that's right. Yeah.
All right, Bill, it's your turn. Norrisworthy.
Dave, I would like to ask if you could elaborate a little bit on why you think the interbreeding was not as much a factor for the loss, or the fact that there's so little DNA of the Neanderthals in modern humans. It seems to me that 3% incredible amount, an amazing amount, that would still be in our gene pool after 70,000 years. And so it seems to me that it would indicate a high level of interbreeding over that time period that they were both in the same place.
Well, but look at Neanderthals and Denisovans. They share 17%. Because they were they were interbreeding for over 300,000 years. So, and they weren't even absorbed into one another. They were still separate species. So I'm not saying that 50% of our DNA would be Neanderthal. The process may have favored one over the other, but anthropologists in general feel that that percentage would be much higher if they had just simply been absorbed. In other words, it would be a blending of the two species together. And it's also very difficult to do because typically, even when two separate species can interbreed, often the offspring aren't fertile. So it's a fairly rare thing for one species to be absorbed into another. And there are other reasons as well, but that's the general consensus. It's not a scenario that has a lot of currency right now among anthropologists.
Okay, thank you.
Welcome.
Thanks, David. And now Linda, I've unmuted you.
Hi, I got in a little bit late, was having trouble getting it going, so I might have missed it. But I was wondering, how do we tell genetics? And does the DNA actually survive that long?
Well, yeah, it does. The process for extracting it is a very complicated chemical process. It's a fairly new process. It's only been around about 10 years. And it's largely made possible because of a process called polymerase chain reaction, or PCR, which is a way of amplifying DNA. So you could take a very minute amount of DNA, one or two molecules, and subject them to this process, and they spontaneously start to copy themselves. And after a period of time, you have a very large sample from a small sample, enough to do sequencing, which you couldn't have done with just a tiny bit. But often the DNA is broken up, and it has to be sequenced once it's been recovered. They use chemicals to, first of all, they need to break down the cell walls in the cells where the DNA is present. And then they have to extract it in a way that it doesn't carry things with it that are inhibitors of the PCR process. And that's another fairly complicated scenario. And I honestly, I don't really understand it. I'm not a chemist, but it's fairly involved. And I know one method they use is they use glass beads. DNA has an affinity for silica. And so they able to mix in some glass beads with the sample, and actually some of the DNA will stick to the beads. It's a very small amount, but again, with PCR, they can amplify it and get a sample that's large enough, large enough to use. So that's a great question. It's I wondered that myself, and I recently have been reading up a little bit on the process. And but yeah, it will last a long time. They think the limit, probably the absolute time limit, is probably about 1 million years, or maybe 1.5 million years. Now you may see it once in a while, reports on the news that, or in science websites or whatever, that they've recovered DNA that's 1.5 million years old, which is actually not, what they're talking about is not recovering the DNA directly, but what they've been able to do is take proteins which are found in a fossil. Proteins are much more durable than DNA is. So in older fossil, maybe all they can recover are proteins. But since they know what amino acids make up that protein, and they also know what genes code to make those amino acids, they could sort of do a reverse engineering and go from the proteins back to what the DNA must have been. But it's not as good as having the DNA itself. It's a little bit spotty, but it has been used to help in taxonomy classifying animals, but it's just not as complete as having the DNA itself. And the only reason, I think the main reason that horse bone that was 700,000 years old produced good results is because it was encased in ice that whole time. which did help to preserve it. And in fact, Denisova cave, which is a permafrost cage, also is very good, has been very good for preserving the DNA of the fossils in that cave. So there is a limit, but you know, it's a pretty long, it's amazing to me that something 700,000, an animal has been dead 700,000 years, they can actually get enough DNA to actually sequence the genome. And by the way, almost the entire Neanderthal genome has been sequenced now. So that's how much DNA they've gotten from Neanderthal fossils. It's pretty amazing. But
That's amazing. I have a second question when you're done with the first one.
I'm done.
Okay. What is your opinion as far as, I noticed with COVID, people who kind of deny the facts are going into crowds such as churches, Trump rallies? Do you think that that's going to affect evolution in any way? Maybe more intelligent species will come out of this?
Well, I hope so. You hate to see that happen to anyone. I don't think belief in nonsense is going to go away anytime soon. But yeah, that's. I think that question was a little bit tongue in cheek, right?
No, I'm really serious though. You know, a lot of us are saying, "Hey, we're going to stay home and be careful," but then there's a group of people who kind of deny science, don't seem to be good thinkers, and they're getting out into groups.
Well, but the sad thing is that not just them, they're going to go out and infect probably a dozen other people. And a lot of those will be smart people, people who don't want to be exposed. So, yeah, that's, boy, you hate to see that happen, these COVID parties and things like that. Oh,
unfortunately, they've probably already reproduced, so it's too late.
Yeah.
Hi, I'm not sure if I can be heard. Can anybody hear me?
Yes, but we have some people who have their hands up first. I'm sorry.
You know, I'm sorry that this is the first time I've used Zoom. So yeah, I got my hand raised. Hopefully it worked.
Yes, is this Jim?
Yeah.
And
I don't mean to
Bella?
cut in. I just
No,
didn't
that's
know how
quite
to
all
do it.
right. No
Thank you.
problem. Glad to have you with us. And
Thanks.
James Young is the next person, and we'll get to you after Jordan, Jim.
Thank you.
You're welcome.
Some of the comments that I've been hearing brought to mind a video. My voice is bad today, I'm sorry. That I recently viewed on YouTube about the history of the theory of evolution. And since the time of Charles Darwin, when he first wrote his books, whatever it was.
Origin of Species?
Yes, Origin of Species. And this video shocked me. I was absolutely shocked. I had absolutely no idea what evolutionist scientists thought early on right after Charles Darwin, including Charles Darwin. But when you think about it, the climate at the time, since I think he wrote that in 1859, somewhere in that area, most people around the world looked upon Africans and Asians and Latinos and anybody who was not Anglo-Saxon, they looked at them down their nose as an inferior species. In fact, some people, scientists, we're not talking about just people, we're talking about leaders, scientific leaders, believed that these groups of people were subspecies or subhuman, And in 1904, they had the St. Louis World's Fair. And they actually brought people from around the world, from Africa, Brazil, and Asians, from Japan and China, and from Mongolia. And they had a human zoo at the World's Fair in 1904, attended by hundreds of thousands of people who were viewing these human beings, and it was a horrible experience, obviously, for these human beings.
I would say two things about that. One is that science, was still in its infancy.
Yes.
Actually still is today. And look at phrenology, the shape of heads and the bumps on the head. A lot of very legitimate scientists thought that there was something to that, which has turned out to be just complete bunk.
Well, it gave rise to eugenics. And eugenics was very popular early on,
right,
and supported by the scientific community. But today, thankfully, because of the new technology that you've been discussing, the scientific community has completely
eugenics
missed that idea, and eugenics is no longer held in esteem in the scientific community at all.
I don't think it ever was. Eugenics is a social development. It's a social
Darwinism.
Well, I think that I would like to just recommend that people, since I had no clue of the history of early theory of evolution, people might want to basically search for that on YouTube. You can search for human zoos, and they actually had at the Bronx Zoo for years a human exhibition, which they claimed was a person who was a missing link between the orangutan and the modern man. And this was a person whose name was Ota Benga, B-E-N-G-A, O-T-A, B-E-N-G-A. His story it's a horrible chapter in American history. It's a horrible chapter of the Bronx Zoo, a horrible chapter in the National Museum of History. But it's important for us to recognize our history.
If I could just interrupt, I'm sorry. We have the benefit of hindsight, and I think for people living at that time, one of the most unfortunate phrases associated with Darwin's theories is survival of the fittest. I don't think Darwin ever used that term. It's been used by people wanting to deprive other people of their humanity over the years, very frequently, because what they think that implies is that if one culture and one group of people aren't doing as well as another, that because they're less fit in some way, they're less human. And Darwin himself, was very worried about that, and he was also very worried about that the principles that he was outlining, which were physical principles, would be applied to society, which is what the Nazis did basically. And so, there was a lot of misuse of his ideas, but yeah, that's pretty shocking to learn about things like that. It happened back then. Hopefully we've outgrown that sort of thing.
Well, one of the interesting things, David, is that Ken Ham from the Creation Museum is using this very information to try to get Darwin's theories removed from schools because they've been used to support eugenics.
Yeah, and that's, it's like blaming the mailman for delivering a letter. It's been misused. It doesn't invalidate the the principles themselves, which are been proven over and over again to be correct. But it's, you know, just because it's misused doesn't mean that it shouldn't be taught. It's a valid scientific principle. It's actually got better supported by evidence than a lot of things that people readily accept as true. So, but from what I understand, Ken Ham's museum is losing money hand over fist. They don't not getting very many people visiting the Art Museum, and hopefully they'll just go out of business because they're just really bad people.
Jim, you had something else?
Well, actually, this movement, which started early on in the right after Darwin's theory of evolution was published, it continues to this day. White supremacists view people of other colors, other bloodlines as inferior, and that's what the claim is, that they don't want to, they want to keep their blood line pure. This basically, it's sad, but this crap continues, and they are still promoting it. This is what you find being pushed by all of the white supremacists, the KKK, and the whole lot of them.
Yeah, but they're not the scientists, thank goodness.
Well, today they're not. Today they're not the scientists, but in the past they were. And if you go back in the history of eugenics, it wasn't that long ago. It's in our lifetime that people were being sterilized simply because of eugenics and the support that was for eugenics in our politicians and our governments. I remember when there were laws that sterilized people, and they didn't have a choice about it either.
Right.
Yeah,
Thank you, Jim.
I had a professor in college, and a genetics professor, who believed that if someone tested below a certain IQ, that they shouldn't be allowed to have children. So
yes,
it's actually it's still some of that around today, but fortunately, you know, the thing you have to understand about race is that it's not. There's no such thing physically as race. Race is a social construct, and white supremacists and other extreme groups like that, they perpetuate the myth that it's a physical reality, but it's not. There's no such thing as a pure race anywhere on the earth. It's completely a social. And Ta-Nehisi Coates, who one of my favorite writers, he commented in one of his books that race is the child of racism. It's not the parent. So I think it's important to keep that in mind.
thanks, Jim Young and David. Jordan, you have a question or a comment?
Thank you, David. That was very interesting. Nice to see your anthropology degree coming into good use here. You talked about this somewhat with Linda, but I was fascinated with the 700,000 year horse DNA. And so I was also wondering, is there a theoretical upper limit? Isn't it possible that with tar or amber or ice that DNA could be preserved for millions of years? And I have of course, I'm thinking of Jurassic Park or something, but I have one more question after that.
Yeah, that's really good, Jordan, because that's one of the ways that DNA is preserved better. Coal is one way, and amber is another way. But it will spontaneously break down and fragment over time. They think right now the upper limit is going to be somewhere between 1.25 and 1.5 million years, regardless of how it's preserved, because it does just tend to spontaneously, it will over time fragment. Never goes away completely, but it becomes so fragmented that it's not useful for anything really, you know. So That's generally what happens. But that's a good question. Yeah, that's considered now to be an upper limit for DNA, regardless of how it's preserved.
Okay. And my second question is regarding the people coming over the land bridge. Was there any evidence of Neanderthal DNA among Native Americans or Canadian Americans? And what about in South America? I wasn't sure whether or not there was evidence that Pacific Islanders made it to South America. So anyway, it's the DNA of the land bridge, whether there was any Neanderthal blood there.
Yeah, Native Americans do have Neanderthal DNA. I'm not sure what the percentage is. I don't think it's quite as much as Europeans, but anyone descended either from Asians or Europeans is going to have some Neanderthal DNA in their blood, in their genome. The only exception would be Africans because they had no contact with Neanderthals. But I don't think I think pretty much any population in the New World other than African is going to other than having African heritage, is going to have Neanderthal DNA as part of their genome.
And just slightly off topic, I was wondering about the whether South Americans had any DNA from Pacific Islanders, or whether or not the latest beliefs were whether it was a land bridge and they migrated south.
Well, yeah, it's actually fairly well known. I'm not really up on it, but they've used genetics, analyzing the genetics of Native Americans to determine where they came from, and they all did come from Asia across the land bridge. And also, there were different waves of migrations, and they're also able to work out approximately when they came over and what wave of migration they were part of. So, but I'm not aware of any evidence that there's that they brought any that South American populations have any admixture of Asians, but of course, South or Pacific Islanders. But then again, by now you wouldn't know because there's probably been some interbreeding going on in modern times between those populations. So I don't know how you would be able to tell the difference.
Okay, thank you, David.
I'm not aware of anything. In fact, that whole theory is probably it's not very well adhered to right now. It doesn't have much, doesn't carry a lot of weight with either anthropologists or historians that the Americas that the New World was populated by people from the South Pacific. Interesting theory, but there's not a lot of evidence right now, as far as I know, to confirm that happened.
Thanks, Jordan. Jim Panzarella, it's your turn. We got too many Jims.
Yeah, hi, thanks for taking it. Sorry if I'm still trying to master this, as I
Not
mentioned.
a problem, don't worry about it.
Yeah, because I put this in chat. So this is from a previous point in the conversation when David mentioned that we humans are still evolving. And I put this in the chat. I'm just going to read it. Are we evolving to be less healthy? Genetic diseases and just plain weak constitutions are now allowed to live and have offspring thanks to modern medicine. So I'd be interested in your thoughts on that, I guess. I'd be interested in everybody's thoughts on it.
Well, I don't, modern medicines haven't been around very long. And evolution is a very slow process. It takes a long time for things to sort of have their effect. So I would think that over time, though, if we kept essentially artificially protecting ourselves from pathogens with vaccines, that we would not evolve a natural resistance to them. but that's such a that's a tough way to get. That's a tough way to do it. A lot of people would have to die. So, but that's you know, I think in 1,000 years we may know something about that, but I think it's just a little bit too early to tell. But that's an interesting thought. I never really thought about that before.
Yeah, I wasn't actually thinking about pathogens. That case has its own characteristics. I was thinking about simple things like if you're born with a weak this or that. Can't think of a good example right now, but I'm sure other people could. But you know, now you can live your whole life. You can live a good life by taking the right medicines and stuff like that. So more than evolving a resistance, I'm just thinking of the effect of, you know, like we were very, very healthy a couple hundred years ago, as near as I
No,
can
we
tell,
won't. No.
looking at the looking at the gravestones, people either died before they were 2 or 3, or they were dying at an old age. And to me, it occurred that maybe it's a natural evolutionary sorting out there. And now that they're not dying at age 2 or 3, it's pretty rare probably. It would indicate that these inherent diseases, people are going to be more susceptible to them because they're having children. So that's my thought on it.
Well, interesting.
It's more a question than a thought. I'd like to hear other opinions.
Well, you know, there's a difference between life expectancy and lifespan. Life expectancy has increased dramatically because of healthcare. You know, we have our healthcare now is so much better than it was 100 years ago. But our lifespan hasn't changed at all, really. You know, there are people in ancient Greece that lived to be in their 90s. You know, if they were lucky, they didn't, you know, have an accident or catch a disease. So there's really no evidence that the human lifespan has changed at all, as long as we have records, you know, as far back as we have records. So, but then again, you know, it's a slow process. So there's just no way to tell right now what the effects are going to be.
And Linda has a question again. I assume it's the same Linda.
Yeah, I had a comment on who was just speaking. I wasn't sure.
It was
Who was
Jim.
asking the question?
I think you're talking about me, who
Yeah.
asked about the evolution of
Yeah, who
the
is me?
de-evolution.
I'm not
Jim
seeing the name.
Jim Panzarella.
Oh, okay. You were thinking, can I think of an example? And what popped in my head was cystic fibrosis, where they used to die as infants, and now they're living long enough to go ahead and have children of their own, passing on what used to be a lethal recessive gene. I know people in their 30s with cystic fibrosis with children. So I was thinking that when you were talking, maybe you were thinking of something like that.
Yes, I was. And there's many other examples that, of course, I can't think of right now, but I will when I'm off this.
Well, the other point to remember is that if it doesn't affect reproduction, it's not going to go away. So if it's something that happens later in life, after you've reproduced, you know, there's no pressure there. There's no evolutionary pressure.
Well, I'm not sure I'm making my point. If you know, I believe a couple hundred years ago, 1 out of 3 kids would die before age 2 or 3. That's a statistic I heard. I have no idea on the accuracy, and that certainly affects reproduction. Because if they died from weaknesses before they were old enough to procreate, then it's definitely something that's going to be changed by modern medicine. Am I repeating the same point over and over again? If I do, I apologize.
Well, yeah, no, I understand what you're saying. I really, don't know the answer to that, and I don't think we will know the answer for probably thousands of years. You know, it's a very slow process.
I
But,
see
it
Jim
is
Peterson
interesting.
waving his hand. Do you want to jump in on this, Jim?
Well, yes. Well, actually, I wanted to go a little bit further and elicit Dave's opinion about the fact that we now have the ability through CRISPR and other gene editing technologies to change the nature of a good many species of animals and plants, including ourselves. And what does it's difficult, of course, to project into the future what this is going to mean, but I suspect that we can make ourselves into wholly different kinds of beings physically and maybe even mentally than we are now. What is your
Yeah, I
opinion?
don't. The problem is you don't know a lot of times what the effect's going to be in the long haul, and right now it's outlawed in just about every country to use that technology on humans, and rightfully so. One reason is that it's still very dangerous. You know, a lot of times you just don't get the results that you're looking for, and it's done with the animals, and some of the mistakes or results have been absolutely horrible. You know, with all sorts of deformities and so forth. So, you know, the good part about it is that, you know, improving crops, that sort of thing, helping to feed people. I mean, there are a lot of good parts, a lot of good things about CRISPR, but fortunately, the state of the technology right now really doesn't allow for that to be applied to human beings. Just not well enough understood. But it's pretty scary thought, though, that, you know, we're having the ability, because any change we make, especially if it's applied to reproductive cells, you know, it could be part of the population forever, you know. So going to require an awful lot of care, and I just don't think it's ever going to be a good idea. But yeah, it's pretty scary when you think about it. You know, it's like nuclear weapons. Are we too smart for our own good? You know, are we going to survive our own technology? You know, that's a question that remains. But that is a pretty scary thought when you think that we have the ability to make permanent changes in a way that may affect our evolution in the future. And not even knowing what the exact outcome is going to be. You know, that's pretty scary.
Thank you.
I'm sorry, Jordan has another question.
Well, yeah, kind of a comment. I'm not sure it's directly related to what Jim was talking about, but you know, even poor eyesight. Look how many of us wear glasses. Poor eyesight could have been a death sentence back in early days. Not to mention broken leg, not being able to keep up with the tribe for whatever reason. So, but I also wanted to comment on the direction of evolution, which Jim had brought up. And as David indicates, evolution is very slow. However, there is evolution going on now, and it's the technological evolution. It's much faster than any DNA changes. And I think our evolutionary future is more likely to do with the merging of our brains and our bodies with computers, the internet, synthetic organs, robotics. As all of that becomes more and more incorporated into our beings, I think that's the future of human evolution, is a marrying of our biology with technology.
Yeah, it's you know, we're already gradually, piece by piece, being replaced by inanimate objects. You know, not carbon-based biology, artificial limbs. I like to fantasize in the long run that gradually will be more and more of us will be non-organic or inorganic, I should say. And eventually, who knows? Maybe we'll be totally inorganic. It could happen. So, but will we survive that long? That's the question.
Yeah.
Will we annihilate ourselves before that happens?
We've got to get through the next couple hundred years, and that's a big question.
Yeah. Thanks, Jordan.
Thank you.
And Jim Young has another comment.
If I can get unmuted here. Okay.
Sorry, I tried to unmute you.
With the comments that were made by Jim Panzarella and the comment made by Jim Peterson, which I think was excellent, and various articles that I've read over the years about scientists modifying various proteins in the genome or whatever it is to cure diseases. For me, this is basically speeding up evolution. And when humans breed, we are changing our future DNA. We are speeding up evolution. For an example of this, what I've observed in my 74 years, when I was a young child, there was not much interbreeding between blacks and whites, and the blacks seemed to be very black. And then when they got rid of miscegenation laws, there's people marrying and having children, and of course these children are beautiful. They're nothing like what the naysayers said they would be like. But I'm looking at this change, and it's a rapid change in the evolution of humanity. If we continue with this process, because of the fact that we now live in an age where people can mix. People can go to Japan, they can go to China, they can go to Russia, they can go anywhere in a matter of hours. They fall in love, they marry, they have children, and we're becoming a homogeny of essentially one, I hate to use the word race because I don't believe in race either, one homogeneous race of people that is hard to make a distinction. But we're actually, in my opinion, we seem to be curing diseases by doing this, and we're improving our life expectancies, I think, because we're actually solving some of these medical issues. You want to comment on that, David?
Yeah, I think you have to keep in mind that all humans share 99.9999% the same genes, right? So the differences in our genomes are very, very superficial. There are some things like sickle cell anemia, which afflicts a lot of African Americans. That's a condition that evolved in Africa because it makes them more resistant to malaria. But it also has a negative effect, obviously. They often die at a young age, people that have that disease. But, you know, there's always been a lot of mixing. There may be more today. I don't think that's has any effect at all on evolution, or that it necessarily makes us more healthy. It may, in fact, make us less healthy. I don't know how you would know, how you could tell. You know, we already share so much DNA that these differences between what we perceive to be races are really quite superficial, and really there is no such thing as race, as you mentioned. But yeah, I don't see that really having much of an effect on anything really. But that's just my opinion.
Can I ask part two of that question? If sickle cell anemia is unique to Africans, and there's interbreeding between Africans and Caucasians, and every time there is another mix, another generation, the offspring are lighter and lighter in color. Now, my question is sickle cell anemia going to slowly dissipate and disappear in this bloodline, or is it going to be a situation where people of light complexion are going to have sickle cell anemia?
Well, I don't, again, I don't, first of all, it's a recessive trait, okay? You can't get, if a white person marries a black person who's carrying that gene, his offspring will not have that, because it takes two people with that recessive gene to pass that along to the offspring. And even that might be an oversimplification. So, and I don't know that skin color among African Americans is getting lighter. You know, that's an anecdotal kind of observation that, you know, often those aren't correct. So, and not to say that you're wrong, but again, I'd like to see some scientific evidence of that. I'm not aware of any.
Well, if you are mixing African Americans with white Caucasians, and you have to have both of these recessive genes present to have sickle cell anemia, apparently over time, you're not going to have the two people with the same recessive gene. It's going to become almost impossible to find two people that have that recessive gene. It would seem to me, which would be an improvement in the health of the human species overall.
Except if you live in Africa and you get malaria and you're no longer resistant to it.
Well, that is another issue.
That's why it persists, because people
Right.
survive when they would have died, you know, because they're resistant.
And just because you're white doesn't mean you can't get malaria or can't get sickle cell anemia, because many, not to get too far deep into this, many slave owners raped and had lots of children from their African slaves. So that's been going on a long, long time. So there's plenty of mixture. And Tony wants to say something. Sorry, Tony, I interrupted your hand. Sorry.
I know that's okay. I put my hand up on the chat too. Well, you know, coming from Brazil, there is more blacks in Brazil than whites. 47% white people and 50 and some brown and black, but it's mostly brown. And just what was Jim who said that they're going to get lighter. Yes, they are, but it's going to take more than 100 years. That's what I think about the United States. You know, with the intermarriage, that's one of the ways that racism is going to be much lesser. Will probably never disappear, but it won't be what it is today, what we have seen 50 years ago and still going on. So it might take more than 100 years, because Brazil never had segregation. And so all the races are mixing, and Brazil today is more brown than white. But we don't have all the problems that we have here. We have prejudice, but not racism, actually. Thank you.
Thank you, Tony. Any other questions or comments anybody wants to make? It's about that time to close out, and appreciate David, your excellent presentation on human evolution. I think it opened up my eyes to some things. I wasn't all that aware of the Denisovans. I can't say it. Denisovans.
I'd just like to say thank you very much, David, because your presentation was very informative. In fact, I think that we could entertain more meetings with discussions on evolution, because there is the field is so broad, and then now that we have DNA that we could talk about as well, I mean, this is a topic that is hugely interesting and can be explored at great length in the future. So I just wanted to say thank you very much for your presentation, and because I still have questions that I'm not real clear on, and I know that you could probably help me out, but we don't have time for that, so I'm not going to say anything more except thank you.
Well, you're welcome. Thanks for all the great questions and comments.
Yeah, I would say it was fantastic. I was only disappointed by the realization that I'll never actually see a Tyrannosaurus Rex live now.
I know.
He's too old.
Well, we can go see Sue at the Chicago Field Museum.
There you go.
Anyway.
I do have a question not related as much to evolution, but somewhat, and that is my understanding of the lifespan of humans is determined, at least in large part, by the telomeres on the end of the cells. And I don't know a whole lot about this whole area, but has there been any evidence that telomeres are changing in any way?
Well, I don't think so, but now there's a whole new field just in the past few decades of epigenetics. It's not just about what genes you have, it's which genes are being expressed. And we all have genes in our part of our genetic makeup that do nothing but turn other genes on and off. And one of the interesting things that's happened recently is in the past few years, it's been discovered that Lamarck wasn't totally wrong, that traits that we pick up during our lifetime that aren't part of our genetics can be passed on to our offspring, because the epigenetics of the parents sometimes can be passed on to the children, to the offspring. So now it's still basically not true that that things we do ourselves that we acquire in our lifetime can be passed on, but I think that's kind of interesting that epigenetics, some of them can be passed on to the offspring and affect their health, actually. But let me just say real quickly too, this is really kind of off subject, but I was watching a show yesterday about the stress that African Americans have to endure having black skin in a society that's based on white supremacy, and all the the things they have to deal with on a day-to-day basis. And there was some recent research done about the what did you say? Telomeres or
Telomeres.
Telomeres, right? They a lot of African Americans, they find that the telomeres get shorter as we get older,
right?
And they make us more susceptible to diseases and disorders. And they're finding a lot of younger African Americans have telomeres that are about the size of 80-year-old white people.
Wow.
So yeah, it's really a lot of really bad effects to the way blacks are treated. And that's why they're suffering so much now in this. They're 4 times more likely to die from COVID, adjusted for population, than white people are. Because they're stressed out, they don't have, then they have the economic stress on top of that. And then they have not good access to healthcare on top of that. So they all have, a lot of them have underlying conditions. And, racism has very real and very bad consequences. And
yeah, I'm sorry, go ahead.
No, I'm just saying we all need to face up to that.
Yeah, I've been really interested lately in reading about microaggression. Sorry, my computer's going off. There's somebody at my front door with our food. But the whole concept of microaggression and the stress that puts on people, especially people with, like you said, darker skin, where it's not really overtly racist, but there's lots of, I just saw an excellent video of microaggressions in action, and it really opened my eyes to the amount of stress that happens every day in people's lives.
I'd like to recommend the book But I mentioned Ta-Nehisi Coates, who's an African-American writer. He wrote for the Atlantic.
Yeah.
He wrote a book called Between the World and Me. If you're a white person and you want to know what it's like to be a black person, which of course we never can, but reading that book, it's about as close as you can ever come. I would really highly recommend it if you want to see what most African Americans have to endure, on a daily basis.
Yeah. Well, thank you all very much. Oh, Tony has another question. Sorry.
I just want to thank Dave. Oh, yeah. I just want to thank David. It was very refreshing. It's science, which is I can understand. Usually I don't like sciences, but this kind of science I can understand. And it's very refreshing because lately all we hear are bad news and politics and all that. So thank you very much. It was very good. Thank you.
Yes, thank you so much. Thank you, Tony. All right, anybody else have anything before we shut down?
That's it. Thank you, David.
All right, good to see everybody.
Thanks, bye.
Bye-bye.
Bye-bye, everybody.
Bye-bye.